Hi, this is Mr. Max with Sankofa Mathematics. So today I am going to do equations, inequalities, and formula. So this work is suitable for learners doing grade 10 and learners doing grade 11, the new syllabus in Namibia, as well as grade 12 learners. And in general, anybody who has problems with equations, inequalities, and formula. So what I've done, I have selected about 6 questions and I'm going to play those questions in the next slide and I will give you time for you to record and to write them down so you can try them on your own. So with question 1, what I ask you here to do is you're supposed to solve these two equations simultaneously. And you have to be a bit careful here. You see that this is a quadratic equation and this is a linear equation. So you expect about more than 4 answers for this particular question. So let's just get into it. Right, so the first thing that you need to do is you need to equate, because both these equations are y equals to or y equals to. So the y values are therefore equal to. So it therefore makes sense to equate them. And what you need to do, since you are dealing with a quadratic equation, you need to rearrange this equation so that it can be in the quadratic equation format where everything is equal to 0. And when I bring in my terms, as you can see, the 3x becomes a negative 3x and the 4 is becoming a minus. And if you clean this up, you are going to be left with 2x squared minus 1x minus 10 equals to 0. Now, you can solve this equation here in many ways. You can solve it either using the quadratic equation formula, or you can use it completing the square, or you can just do what I do, because this equation does factorize. So remember, when we are talking about factorization or solving quadratic equations through the method of factorizing, we are going to look for two numbers that you multiply, give you the negative 20. So that negative 20 comes from, remember, the quadratic equation format is in the form ax squared plus bx plus c is equal to 0. So what eventually this c, when you multiply a times c, you get 20. It's this value multiplied with that value of c. So for example, it is the 2 that you have, this 2 times the negative 10. Well, the 2 times negative 10 gives you negative 20. And now what we are doing also is we are going to then find then two values. If you add them, they should give you the value of negative 1. So we're going to look for two numbers such that when you add them, they give you negative 1. And those numbers happen to be 4 and negative 5. So when you say 4 times negative 5, you get negative 20, and 4 times, or 4 plus negative 1 rather, or 4 plus negative 5 gives you negative 1. So the two numbers I'm looking for is 4 and negative 5, which will kind of split up that term there in the middle. And when you do that, you realize that you do have got something like that, for example. Now, what I did there is I have indicated in red those two values there. So now you've got 4 terms here on the left, so I can actually factorize them here. And we're going to factorize them all the way up here. You realize that we are dealing here now with a common factor of 2x. That is why I put it outside the bracket. And inside we'll have x plus 2. And negative 5 is common between negative 5x and negative 10. That is why you have the negative 5 outside. And I have put the common factors that you get. You should get identical brackets like this. And you write them once, and everything outside the bracket you write in its own bracket. So if you multiply and you get 0, it means that one or two of the factors has to be 0. So in this case, x plus 2 is equal to 0. That means if you find that ever that x is you input there, you get a 0, because anything multiplied to give you 0, one of them has to be 0. Or this whole 2x minus 5 should equal to 0. From here, you can start solving the equation. Well, the first one is x is negative 2, as you can see when you move that negative 2, that positive 2 over. And the other one will be x is equal to 2.5. So this is the solution for this particular equation. And this is how you should approach it. Again, as I said, no need for you to try out solving this equation using the quadratic equation formula. Normally, when you get something like this in examination, most of the time, your equation that you're going to get eventually will factorize. And sometimes they might even give you things like show that when you do that, this gives you this. That means you are supposed to handle this and get to that. Eventually, when they ask you to still solve it, you'll still be able to solve the equation, even if you can't follow that. Right. Let us look at question 2. Now, question 2, you have got a quadratic equation. But you are supposed to solve this equation by completing the square method. That means you're not going to use like what I did before, using the method of factorization or factorizing. In any case, this equation does not factorize. And what is an indicator is the degree of accuracy that is specified here. Whenever you're told that you're supposed to solve a quadratic equation, and then they're telling you to give your answer correct to certain significant figures or decimal places or what have you, then it most of the time, or it definitely means that the equation doesn't factorize. You know, the way where you say look for two numbers, give you -12, and if you should add them, gives you +3. Right. So one thing also that you need to understand is follow the instruction, because you are told you are supposed to solve it by completing the square. So therefore, you should not use the quadratic equation formula. So what I like to do first, I like to move the constant term over. As you can see, it becomes a +6. All right. And then I divide throughout by 2 in order for me to have the coefficient of the x squared term to be 1. And also, I do not like to work with decimals because it's easier for me to deal with fractions. And I'll show you when I bring in a little bit of side work here. Now, there's one little step that you need to complete before you continue. That is, you find half of the middle term, half of 3 halves, yeah, and you square that. So when I take b over 2, which is the general formula, all squared, I separate my b times a half, because dividing by 2 is the same as multiplying by half. Right, and the reason I did in that way is because this is a fraction. Now this part in red is the part that I multiply the fraction. 3 times 1 is 3 and 2 times 2 is 4. So I'm not squaring it yet, and there's a reason why. You simply take that part there that is in the fraction, and you simply put it here in a squared form here, x plus 3/4 all squared. Now, in my previous videos, if you have a look through most of the work that I've done, you'll realize that if you were to multiply this out, the 9 over 16 is in there. So that is why I take that part first, and I just say equals to 3 plus now the square of 3 squares 9 and 4 squares 16. So now you can actually start solving this particular equation. All right, so when you're doing the right-hand side, you get to 57 over 16. Now, what is important, and this is why this particular question will ask you to give your answers to, say, 3 significant figures, is because you are supposed to get rid of that square. And the only way to get rid of that square is by taking the square root of both sides. Now, when you take the square root of 57, you will realize that the square root of 57 is going to be an irrational number. So when you're dealing with irrational numbers, your answers will also be irrational. Hence, you are supposed to give it to certain significant figures. Right. Also here, it's better that you also get it that if you are dividing, then it's the same as you are squaring each, the numerator as well as the denominator. And this is quite powerful. All right. And something else that you should realize, whenever you take the square root of a number, you have 2 possible answers. It's either going to be positive or negative. All right. Like -5 times -5 gives you 25. And 5 times 5 gives you 25. So therefore, you can say, for example, that the square root of 25 is going to be positive as well as a negative number, because if you were to multiply a -5, for example, times another -5, it will still give you these 25 in there. The same applies for if those numbers are going to be positive. As you know, that whenever you multiply, for example, 5 times 5, you will still get the same answer. So it's going to be the same as you multiplying 5 times 5. Excuse the handwriting there. So there is two possibilities, two answers. Hence, you see I have the plus and the minus here. So if you do find the square root of 57, so there's just a small little error here. The square root of 57 will still remain there. All right. The square root of 16 is definitely going to be 4. Now, when you are done with all that, the only thing for you to do is to take this negative or this positive 3/4 and becomes a minus. So you're subtracting it basically. And I write it on this side because of a very simple and straightforward reason. So if you have a look, you have the same denominators. I can actually put them all over the same denominator. And this is what you're going to get on your calculators. One answer will be positive, the square root of 57. And the other one will be minus the square root of 57 as two possible answers. All right. So one answer here. Now, if I have to give this answer correct to three significant figures, remember significant figure is the first non-zero digit. The first answer will be 1.14 correct to three significant figure, and the second one will be negative 2.67. Now, what you also need to realize, if you take this rounded answer and you sub it in here for x, you're not going to get 0 really. But if you take this answer here, the one that you have in third form, and you punch it in for x, definitely will give you 0. And that's the way that you have and that you look at this particular question. Now, question 3 is an inequality. One thing that you should be very careful when dealing with inequalities is this idea of cross multiplication. And I'm going to explain a little bit more in this question when I get closer to that part, why you shouldn't do that. Rather follow the steps that I am indicating whenever you're dealing with such an inequality. Okay? So we're going to make the denominators the same first. And the LCM of 8 and 3 is 24. Because 8 times 3 gives you that 24, and so does 3 times 8. And that is why the top one, I'm multiplying it by 3. And also, put those expressions in brackets. Otherwise, you will simply multiply the 3 with the 2x and not with the negative 5, and therefore making everything of yours to be wrong. Now, after I do that, I still keep them there. Can you see that? Now, once you multiply, and this is what this particular part means, if you multiply here by 24, the 24s, they cancel. So if I also multiply this side by 24, and the reason why I'm doing that is because I want to clear the fraction, okay? I want to clear this fraction, leaving me with those numerators, okay? Can you see? And it helps to do it in that particular method. The idea that you have two denominators which are the same, it doesn't just disappear, right? It's just I'm multiplying both sides, this side by 24 and that side by 24. Now I'm collecting like terms, and I've done here is the 8x becomes a minus and the 15 becomes a positive. Right, up until this point, this is where I am. Now, the coefficient here is negative 2, and this is going to stress why I said do not start cross-multiplying like many of you think to do. If you look at here, so before I continue here, let's bring in a question so you can see. We know that 4 is greater than 2. That is correct, is it not so? But is negative 2 greater than 1? Let's say I'm dividing this 4 by negative 2. When I did 4 divided by negative 2, I get negative 2. And if I take this 2 and I divide it by negative 2, so here there was supposed to be negative 2, right? So if I take that and I divide it by negative 2 here, I'm going to get negative 1 as an answer, okay? And we know that negative 1, or negative 2 rather, is not greater than negative 1, okay? It is not. It is actually smaller. So therefore, in order for the whole statement to be true, okay, that means we need now to take the inequality sign and we need to swap it around in order for it to be correct, for the statement to be correct. So this is also going to happen here because we are supposed to divide throughout by negative 2. And because we're dividing by negative 2, as I've indicated here, the statement does not become okay anymore. So in order for it to be okay, you need to then definitely change the inequality sign, okay? So once we do that, you'll realize that I said dividing, so the inequality sign, can you see I have changed it here because I'm dividing throughout by -2. And once I do that, I am going to get -23.5. So do not, and I repeat, do not write equal signs here. We're not busy with an equation, we're busy with an inequality. Right, the next question here, you're supposed to solve these equations simultaneously. So since both of them are equal to 7, you can actually just, equate them. If this whole stuff is equal to 7 and this whole stuff is also equal to 7, then this stuff, as I like to say, can be equated, okay? And you can actually drop these denominators since they are the same. You can just go ahead and drop them, okay? And from here you start collecting like terms, all the terms containing x to one side, and all the terms containing y to one side. Well, you realize that the value of y will be 0. Now, in order for you to find the value of x, you can simply take this value of y, which is y equals to 0, and you can substitute it in any one of these two equations, 1 or 2. It ultimately doesn't matter in which one you put them in. So if you put it -0, whether this was plus or -0, that whole stuff there becomes still 0. So if you cross multiply, you realize that you have 2 times 7, which is 14. Therefore, the value of x should be 7. So this is the solutions to this particular question. Now, I know that some other learners or people would have used the ways of using 2x plus y is equal to 14. That means multiplying that side there by the 2 as well as here. And then you eliminate, okay? And what you do is you eliminate the y's. And the way you eliminate the y's is by subtracting, or by adding rather. So when you are adding here, you realize that y plus negative y will give you 0. So this actually will definitely cancel out these two. And that is if you add these two equations. Suppose you are saying that is your equation 1, and you're saying this is your equation 2. So when you add 14 with 14, you get that. And when you add these 2x with 2x, you get this answer. So this is going to give you x equals to 7. And then you simply take that answer and you substitute it back into your equations in order for you to find what the value of y will be. It still will give you the same answer. It will still generate the same answer where x is equal to 7 and y is equal to 0. Right, question 5 deals with a value of substitution. The first one, you have to substitute. That means we have to take out that value of y, and we have to substitute with 36 in order for us to find what the x will be. Suppose y is 36. Also worth noting, they are using a square number here, because the square root here of a square number will be definitely a whole number. Okay, so if this was some other value like a 5 or a 37, it would make this whole thing to be, again, as I said, irrational, and it probably would have asked you to give this answer to a certain degree of accuracy. Right, so when you do that, I arrive at 6/9 because the square root of 36 is 6. It's better we just take the positive value because we just look for that. And well, I like to write my 1 cleverly as 9/9. You can simply use a calculator. You should be able to get the answer, which is 3/9 in its simplest form is 1/3. Right, now we need to rearrange the equation. That means we're supposed to make y the subject of the formula, and I have put it in red here. So everything needs to move to the left and y should be alone. So the first thing I get rid of that positive 1 and I put it here. Can you see that now I'm putting it in brackets? And there's a very important reason for that. Now there's something here that I need to explain a little bit so that you don't get confused as to my next step would be. When you have a fraction, all right, let's suppose it's this particular fraction as it's there. It could be written as the minus of the numerator, okay, or it could be written with the minus being at the denominator, because the whole fraction is negative. So what I do when I get rid of that -9, as you see I'm writing it here, is I have multiplied throughout by -9. Okay, so that is what I have done there. The reason is I want that square root to be positive. I want the y value, so there's no use in leaving that negative value there. Okay, so once I continue, I'll realize that from here on, you now multiply out the brackets, and if you multiply out the brackets, you definitely will see that here you're going to get a 9x, which is a negative 9x, which is what I have here. And here you must be but very careful, and this is where a lot of students tend to make mistake. A negative times a negative, yes, gives you a positive 9. So this is supposed to be again positive 9, as I say there. All right, so the negative times the negative gives you a positive 9. So when I continue with this particular statement, you realize that I end up with, I just swap it around by putting 9 minus 9x is equal to the square root of y, and obviously that is going to give me all squared. Actually, I can leave my answer like that, but what I like to do is I like then to, sometimes it's not necessary, but if you do that, you can also multiply out that particular bracket and it will give you that value there. Right, with the next question, as I say, I like to throw in a spanner in the works. This is a question that you see and that a lot of learners have asked me to assist them with this one. So this question, when you read it, it says, what rate of interest, that means we're looking for R, compounded annually, all right, every year, is required to triple an investment that's supposed to last 29 years. So the best is to use the compound interest formula, because we are looking for R in the compound interest formula. Okay, so somehow we're going to also make something somehow the subject of the formula, but then it's very important that we need to find what is that particular value of R. Suppose we are given information like this. So let me bring in what I mean by the investment. The investment could be for this amount here. So I'm just going to say 3I, or I, to represent the amount that or the investment that the person is putting away. And the answer what I need to find out, after an n number of years, my investment should be tripled. That is why I have 3 times I here. Okay, so the first thing I do is, let me write down what I have. Right, so I know that n is 29, and I will get rid of this I by simply dividing throughout by I. The reason I do that is because when you divide the i's together, they sort of kind of cancel out each other, as you can see there, leaving you only with that whole number here. And that is the point that I was looking at when I was doing that particular question. Now from here, you are supposed to find R, but you have this index here, so it's a little bit tricky. So either you use indices, which is not advisable because you will not be able to do it, all right, and logarithms are the ones that is going to assist you. So what we do is we take logs on both sides, and the reason why we take log on both sides is because we can actually drop that using the power law, and we can bring that 29 right in front, and it will be, the power law requires you to do that. The 29 is here, which makes it a little bit easy for us to deal with. Now, a little bit of something that you should know, that log of, I don't know, let's say log 29, all right, let's say is equal to something. All right, so we need to be able, and this is what I do here, and I hope you're not getting confused. This is a log of base 10, okay, is the common log. Common log can be written then as 10 raised to the x power is equal to 29. This is basically what you can do. That means you can actually go back and forth. You can write something in log form, and then later on I'm going to write it in exponential form. So first I'll get rid of this 29 by dividing throughout by 29, and then you realize I put log base 10 here because I want to get rid of this log here. So I'm going to use this 10 as just as I indicated there, by then raising, all right, using that same method where I say base 10 raised to this whole stuff here. So that's basically 10, the base, raised to the power of log 3, okay, divided by 29. Now this is a calculator value which I can bring and show you what it's there, but because I don't want to deal with that long number, right, I am just going to leave it like that. You can actually have calculators that can assist you, where you can actually punch this thing in just as it is. Okay, so that is basically what that particular part is. So from here now, it's going to be easy for me. So first I need to get rid of the positive 1 by subtracting it. So remember, this was 1 point something. So if I subtract, I get 0.3, blah, blah, blah. Okay. But I'm still keeping it like that. So it's totally up to you. Now from here, I have to get rid of this 100. And the reason, or the way we get rid of 100, is we multiply both sides by 100. Okay. So what you do on one side, you do on the other side. And that is why you see I multiply here by 100. Now remember, this is actually going to give you a value if you punch it in like that, which is 3.86 blah 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 blah. Okay, so now you can give your answer definitely to three significant figures, which is 3.86%. And that is how this particular question was to be done. So have a look at it. It's a very interesting question. As I said, I like to throw in spanners, and I'm going to do this for every 6 questions that I'm going to do from now on of all the videos. Right, that brings me to the end of this particular presentation. So don't forget, please, to subscribe to my channel, and also you might find a few things that is valuable on my Google Classroom. You can find these codes if you have a look at my other videos, and you will see that I have put all the codes from grade 8 to grade 12 where you can get assistance with whatever you are struggling with. I also put this very same questions on my grade 11 or grade 12 Google Classroom, so you can actually download and print out the questions, and then you can actually do them and have a look at the video to see if you are on the right path.